Okay, so now I'm going to go over the Chapter 10 problem set question number 6. So this is a t-test using a one-tailed example. Okay, so to figure out, first of all, I have to figure out the null and the alternative hypothesis. To find that out, I have to kind of understand what the study is about. And so a counseling psychologist is looking at economic hardship and relationship longevity, blah, blah, blah. This third sentence, the third paragraph is the most important. The psychologist thinks that couples living above poverty level will have a greater relationship satisfaction than couples living below the poverty level. So this is a one-tailed test because it is predicting a direction. I also know it's a one-tailed test because it says it in the title. But because it's a one-tailed test, I will not use the equal sign. I'm going to be using these directional signs. Okay, so the alternative hypothesis is that couples living above poverty level will have greater relationship satisfaction than couples living below. And so right here for my alternative hypothesis, I have couples living above the poverty level will have greater satisfaction than couples living below the poverty level. So I'm doing the greater than sign. And so then the null is easy because it's the opposite. It's less than or equal to. I know that this is a one-tailed test because I'm predicting a direction. So the psychologist collects the data, a group of 39 couples living above poverty level, and a group of 31 couples living below poverty level. So the degrees of freedom, remember that I have to combine my two groups. I have to combine my 2 degrees of freedom. So my first group has degrees of freedom of 38, and my second group has a degrees of freedom of 30 because it's n minus 1. So it's 38 plus 30. So that gives me a total degrees of freedom of 68. So now I have to find the critical t-score for an alpha of 0.05. So I have a degrees of freedom of 68 and an alpha of 0.05. So now I can open up the table. So I am looking for the proportion in one tail because this is a one-tailed test. And I'm using an alpha of 0.05, so I'm in this column right here. And I need to scroll down until I find the degrees of freedom of 68. Okay, so 68 is between these two right here. And so I have to choose between these two critical regions. And so I'm going to choose the more conservative answer, which would be the one that is further from 0. So I'm going to choose 1.671. And I see it right here. Okay, so now I'm ready to calculate the T statistic. But before I can do that, I have to calculate the standard error. And before I can do that, I have to calculate the pooled variance. So let me do that first. I need to pull up my whiteboard here. So that's the formula for standard error. Actually, let me just get another whiteboard here. The formula for the pooled variance, let me check the PowerPoint so I can make sure. So the pooled variance is sums of squares 1 plus sums of squares 2 divided by degrees of freedom 1 plus degrees of freedom 2. Okay. Now, when I go back to my, I don't need that anymore, my problem up here, I see that of the information I got, I have n, so I have the number of couples, I have the mean for each group and the standard deviation. So I don't have the sums of squares. So first, to calculate the pooled variance, I need to find my two sums of squares, because the pooled variance is sums of squares 1 plus sums of squares 2 divided by degrees of freedom 1 plus degrees of freedom 2. Excuse this messy handwriting. Okay, so before I can get that though, because remember they gave me standard deviation, not sums of squares. So to get the sums of squares from the standard deviation, I have to take the standard deviation and square it and multiply it by degrees of freedom. Okay, so now I'm going to do that for each one of my groups. So my first group had a standard deviation of 9. So I'm going to take 9 squared times degrees of freedom. So that would be 38 because it's n minus 1. And my first sums of squares is 30, 78. Okay, so I'm going to save this number. Okay, and my second group had a standard deviation of 12. So I'm going to do 12 squared times that group's degrees of freedom, which is 30. And I end up with 4320. So I'm going to add these two together. And I get 7,398. I'm going to divide that by my 2 degrees of freedom together, which is 68. And I get a pooled variance of 108.79. Now, 79. Okay, now I can take that number and I can plug it into the formula for my standard error. But first, let me answer it down here. The pooled variance is 108.7941. That's exactly what it is. Okay, now I can calculate my standard error. So I'm going to go back to this whiteboard. So the standard error is the square root of the pooled variance divided by each n. So my pooled variance in both cases is 108.7941. And I'm going to go out 4 decimal places because that's what it says in MindTap. So my first n was 39. And the same number I'm going to divide by 31. Okay, so let's get some calculations. First of all, I'm going to copy this number so I don't have to type it in each time. And I'm going to divide by 39, and I get 2.7896. Okay. Now I'm going to take the same number divided by 31, and I get this number, and I'm going to add 2.7896, and I get this number, and the last step is to get the square root. I didn't write the square root over it, but it's an important step. Okay, so my standard error, it looks like 2.509. There it is. Now, I can calculate the T statistic. So the T statistic is my mean difference divided by my standard error. So let me go find my means. My first group had an average of 51.1, minus my second group had an average of 45.2, and that gives me 5.9. And I'm going to divide that answer by my standard error that I just calculated a minute ago. And I end up with 2.35. Okay. So remember my critical region was 1.671. So if my t value is past that, then it is in the critical region. Well, 2.35 is bigger than my critical region, so my critical t of 1.67, so it's definitely in the critical region. It does lie in the critical region. Therefore, the null hypothesis is rejected. The psychologist can conclude that couples living above the poverty level have greater relationship satisfaction. Let's see if I got it all right. And it looks like I did.